Hello world, this is Clyde, and my name's Nick, and we're here to show you our Markforged booth here at CES. This is Clyde here. Hello. He actually was mostly printed on our Markforged printers on an X7, which is our industrial series. So I'm going to show you around the booth a little bit and show you some of our high-strength 3D printing. All right, what? Yes. So we've got our X7 over here, which is our industrial series printer. It's working pretty hard. It's making a thermoset mold right now. You know, this is used to make some parts on the for the crash test dummies for Humanetics. Keep walking over here. We got a custom vise here. This is reinforced with continuous carbon fiber. This is made by one of our customers. They use to hold stock while they machine it. Lots of photo ops happening in the booth right now. All right, over here we've got some brake levers. You can see Kevlar. High strength, high temperature fiberglass. My personal favorite, not gonna lie. Doesn't get enough love. And we can move over here. We also got metal 3D printing up in here. Composites, metals. You know what I'm talking about? Yeah, I get what you mean. Here's our Metal X. He's working hard, as he always does. Right now he's printing the needle bearing housing. Look in there. Or like you had like a enclosure that
so humidity is not a big problem, but temperature is a...
You want it to be the right temperature.
So what is the temperature inside?
Alright, and our Metal X can print all sorts of materials. Let's check them out over here. Here's some impellers, 17.4 and H13 tool steel. These are metals that our customers are currently printing in right now. All-purpose stainless steel, also H13 tool steel, super good for high impact or high temperature uses. Injection molds are a huge industry that we're getting into now. You can print molds for a lot cheaper than they can be machined in the shop. We're gonna be coming out with Inconel A2 here pretty soon. My personal favorite, titanium. Ooh, shiny. Yeah, so really excited about all the materials we're coming out with pretty soon. And our metal printer is actually so precise we can print threads, so you can check this out all the way down to M3 size threads. These screws are all threaded perfectly in here without having to tap the holes. All right, now let's see some more parts that we're printing on our printers over here. So we've got the desktop series over here. Right now it's printing an end effector for a robot. If you look inside, you can see that it's being reinforced with Kevlar. Really lightweight, really tough material that allows companies to save money by making that end of arm tooling. Got some more fixture examples over here. Welding fixtures for with our high temp fiberglass. Inspection fixtures reinforced with carbon fiber. And over here, my personal favorite is the Haddington Dexter arm. We've got Kent over here. He's actually training the arm. So Haddington uses Markforged 3D printers. They have a Mark II, and they use it to print nearly all of the parts on this robot. So right now he's actually training the robot by moving the arm around, and the arm will be able to repeat the exact motions that he's doing with a 50 micron accuracy. And the carbon fiber that reinforces these parts allows to have that stiffness that's required for that really high accuracy. All right, now here we see it going. This is what Kent was just training it to do. And robotics is a huge industry for us. Wherever people need to print really lightweight, really strong parts, they can turn to our printers, whether it's composite or metals, to do the job. some spare parts from the robot over here. So Haddington is doing an amazing thing where they're actually 3D printing optical encoders. And so you can see the slits on this encoder here. They're able to get 8,000 measurements per slit, which is about 1 million for one revolution of the optical encoder, because they're wizards and they're super smart. And they print their stuff on our printers, which is awesome. And this is reinforced with carbon fiber, much like all of these other parts are. As I said, to give it that stiffness and strength for being an end-use part that has ultra-high precision. Again, like I said, this has precision of about 50 microns. I think they're working down to getting 30 micron precision with its movements in 3D space, which is going to have huge implications not only just for robotics research, but for manufacturing and rapid prototyping of robots, and even beyond that. All right, let's keep moving this way. Daniel's got a little crowd over here. He's pretty popular around here. He's got all the knowledge up in there about our printers. He's been working here for about 2 years. So the plastic material is kind of the one thing that we're really excited about now is H13 tool steel. We just came out with it. This is an example of some wear-resistant inserts for a cradle that is holding an automotive part. And H13 can be used for a ton of things, and we're shipping it now. So for example, wear-resistant inserts like this, tooling, metal tooling, and injection molds are a huge one. When you're able to 3D print injection molds, you can add conformal cooling chambers to it and make your injection mold process a lot more efficient. For example, here's an injection mold right here. Tooling for injection molds can cost thousands to tens of thousands of dollars, but if you're able to iterate it on a 3D printer in a matter of days, the cost goes down orders of magnitude, literally 100 times cheaper. Here's another example of soft jaw. This soft jaw was printed on our composite printer. And this is actually a metal printed part in here that was machined after it was printed. This is a needle bearing housing with a pretty complex shape. And so being able to 3D print this complex shape into the soft jaw allows you to have reliable, strong work holding. And then you can machine our metal parts just like any other metal part that you might have that's not 3D printed. And yeah, this is, you know, Charlotte having a good time over here, chatting it up with some Haddington folks. Woo!
He's got a Facebook.
Say hi, everyone. Hey.
What's up? I'm enjoying your chair and your booth very much.
Good. We're glad. Having a little Eiger software demo over here. Oh, it's looping. Eiger, my impartial opinion, my favorite 3D printing software out there. The cool thing about Eiger is that it's cloud-based, so I can sit at home and kick off prints at work, and I actually never have to go to work. It's a pretty cool thing. I'm just kidding. But I can kick off prints from home, and all you do is press go after you put it through the slicing software. It slices your part, plans out all the paths. You can just skip the cam process like you don't get to when you're doing CNC operations. And then when you press print, you can literally be 100 miles away and the printer will start printing your print. And all you gotta do is be there to take it off the bed when it's finished. And another cool thing about Eiger, besides that it's cloud-based software, is that you can plan out your fiber reinforcement. So, for example, this part's gonna be reinforced with Kevlar. And we're gonna go in just a second into the internal view. And what this allows you to do is plan out on each layer how much reinforcement you want in it, so you can reinforce it based on the loads that are gonna be felt by the part. So we're gonna go into the internal view, and you can see these are the layers right now that are gonna be reinforced with Kevlar. And then you can go into the two-dimensional view, and you can go layer by layer and choose exactly how you want it to be reinforced. It's a super powerful tool that you get for free with the printer that gets you the best parts possible. That's the, I mean, I don't know, that's the gist of the booth. I hope you guys liked it. I don't know. I thought I had one more thing to say, but I guess not. That's the entire booth. But thank you for joining, and I hope you liked it.